Alrighty then. Welcome to Dale Tutor. My name is Mr. Witness Urayai, and today I'm breaking down on experimental techniques to get you fully prepared for your O-level and IGCSE science. Whether you're taking ZIMSEC or Cambridge, perhaps you could be doing combined science, chemistry, and probably physical science. I took this presentation from my physical science presentation, but experimental techniques does cover all tiers, whether it's combined science, chemistry, or physical science. Those who are doing Cambridge particularly, you will be able to see that each slide may be covering core and supplement. Please do take note that if you're doing pure sciences, whatever is covered on core, you must have foundational knowledge on everything. So I would love to welcome you to experimental techniques. And in this lesson, I will particularly cover on measurement. And then in the next video, I'll be covering on chromatography and purity. And then the next or the third presentation that you will then get to see will be covering on methods of purification. Now, this is what we're going to cover. We are going to cover on measurement, accuracy, reading scales, choosing apparatus for time, temperature, mass, and volume. Chromatography and purity will be covering in the next video, as well as methods of purification. You will also be delighted or given to your delight exam practice questions, whether it's multiple choice as well as structured questions. Marking schemes will obviously be provided to students who sign up for classes. Now, measurement. We begin with measurement. In the exam, you must be able to come with to name, in fact, suitable apparatus, read scales correctly, and so to be able to watch diagrams closely is a requirement. Your observation skills, you need to fine-tune them to be able to come up with accurate answers and responses. Now, before naming any apparatus, I want you to master two words: accuracy and precision. And remember, every reading is taken at eye level. Looking from above or below the scale causes parallax error. So as you can see, this will be too high. It may give a false reading, or you might you might end up viewing the reading as lower than it is intended to be viewed. If you read too low, the reading may appear a little bit higher, but hence you are encouraged to read at eye level. Taking readings like this from this angle or from this angle will cause what is known as the parallax error. All right. Now let's have a look at what we have here. Measurement means finding the size of a quantity, time, temperature, mass, volume using suitable apparatus. That's what measurement means. Accuracy, how close a reading is to the true value. That's accurate. Precision, how fine the scale divisions are. Smaller divisions obviously give more precise readings. Always read at eye level to avoid parallax error. Record readings with the correct unit. So if you're measuring time, it means that you're going to be using seconds, degrees Celsius for temperature, mass for grams for mass, as well as cubic centimeters for volume. Now, 3 ways to measure time. The stopwatch is precise to 100th of a second. As you can see, we have the stopwatch here. And then obviously we do have what is known as the stop clock. But normally with this one, people tend to have problems with reaction times. Let's have a look at what we have here. Stop clock, analog, reads to the nearest second. Good for long timings, e.g. rates experiments over minutes, or rating experiments over minutes. Digital stopwatch reads to the 100th of a second. If you go back to your mathematics, you notice that this is a 10th of a second, and this position represents 100th of a second. So the digital stopwatch is more precise, but human error, meaning that can affect it, can limit its accuracy. Human error, perhaps reaction time is about 0.2 of a second, and hence it might inhibit accuracy. Data logger with sensor is more appropriate, especially in fast recordings like athletics competition, where athletes may be ahead of each other by just a fraction of a second. Data logger with sensor records automatically, removes reaction time error, and takes many readings. Exam note: for repeated timings, repeat and average to reduce random error. So these are the precautions that one must take when using a stopwatch, perhaps, or a stop clock. Normally, we say that we repeat and average to reduce a random error. Now, we are here on temperature. So before I get into it, for temperature, the laboratory thermometer reads to 1 degree. The digital probe to 1/10 of a degree, which is more accurate. Perhaps we may have this digital thermometer here, as you can see. This decimal place after the comma represents 1/10 of a unit, 1/10 of a degree. One of the things that people must take note is when you're using a thermometer, you must keep the bulb in the liquid. You must also stir and wait until the reading is steady. All right. Now, as you can see, keep the bulb fully in the liquid, stir before reading, and wait for the reading to become steady. Read at eye level at the top of the liquid column. You must also read at eye level. At the top of the liquid column, what do they mean? They mean at the very top, at the very last here, is it? And then that's where you make your readings at eye level, and that to also prevent the parallax error. Measuring mass. Now, before we proceed, mass comes from the top pan balance. We can obviously measure from a top pan balance. The skill examiners love is to, probably they like introducing the zero error, whereby a balance has a reading already on it, and therefore you must be able to cancel that zero error. So let's have a look at what we need here. Top pan balance measures the mass directly, typically to 0.01 gram. All right. Now, we also have the following. You have to place the container on the pan, then press tar 0. So only the substance is weighed, because obviously the pan has its own weight. So I believe that there is a button that you must press after placing the pan, so that the weight of the pan won't be included. Precautions that the student must take when recording mass is that the windows must be closed. Moving air changes reading on sensitive balances. Weighing by difference: mass of container plus solid and minus mass of container equal mass of solid, because the container sometimes itself, let's say we have something that we want to weigh precisely. It could be the mass of meat or grain, particular grain. The pot itself has its own weight. So you want to measure the mass of container first, and then now you've got mass of container plus whatever it is, maybe solid. And hence you have got this mass of container plus solid. Maybe it could be 500 grams. And then mass of container, it could be maybe 100 grams, meaning that it means that the contents are weighing 400 grams. Now, measuring volume 1. The measuring cylinder is quick but approximate. Indeed, the bottom of the meniscus sits on the scale mark, that is the reading taken at eye level on a level bench. So the general purpose for approximate volumes, obviously, is general purpose apparatus for approximate volumes, e.g. when you approximately want to measure 25 cubic centimeters, 100 cubic centimeter sizes, reads to the nearest 0.5 or to the nearest 1 cubic centimeter. The least precise of the 3 volume instruments obviously is the measuring cylinder. A precaution that the student must take is it must be placed on a flat bench, let the liquid settle, then read at eye level. Water curves upwards at the glass, so normally the water tends to curve upwards. This curve is called the meniscus. Therefore, you must read at the bottom of the meniscus, which is more clearly illustrated in exercise books. Now, we have measuring volume 2, where we want to be more precise. We have the burettes. Now, these two are the accurate volume instruments, the burette and the volumetric pipette. The burette delivers any volume you choose, and its scale rounds downwards from 0 at the top. So you'll find out that the 0 mark will be here, and then we have some marks increasing as you go downwards. The volumetric pipette delivers one exact volume. So take note that it delivers one exact volume very accurately. So fill using a pipette filler, never by mouth. Graduated pipettes measure a range of small volumes, but we are talking about this one, which measures one exact volume, whereas a burette, it measures variable volumes to about 0.05 cubic centimeters, also to 100th of a cubic centimeter perhaps in this case. So let's have a look at what we have here. So we have a burette here, delivers any chosen volume used in titrations. Scale increases downwards from 0 to probably a given amount. Volume delivered equal to final minus initial reading. So you must be careful there. And then over here we have something that delivers one exact volume, and we'll be delivering more resources on which you can see how the burettes and volumetric pipette works. Now we have the following. All right. Choosing the right volume operators. For instance, they may even ask you in the exam, they'll give you a particular quantity or a given situation, and you should be in a very good position to point out which apparatus must be used. So measuring cylinder approximate volumes are probably to 1 cubic centimeter precision. Example, about 50 cubic centimeters of water for dissolving. They may say Tabo or Tabani or Rutendo wants to measure about 50 cubic centimeters of water for dissolving. Which instrument must he use? Therefore, you will know that, well, I think this has been written to a unit. Since it has been written to a unit, maybe you want something that is approximately 0.5 to 1 cubic unit. Hence, measuring cylinder will be appropriate. Burettes, they might say Tavani wants to measure the volume of an acid for in a titration. Once you know that, then you want to perhaps refer to the burette. All right, and the burette is rightly accurate to 0.05 cubic centimeters. Volumetric pipette, one fixed volume accurately, whereas the burette variable volumes accurately. But volumetric pipette is one fixed volume accurately, and if you hear something like Simpiwe wants to measure exactly, keyword there being exactly 25 cubic centimeters of an alkali, then you know that is a volumetric pipette which measures. But if it's a variable amount, 25.3 cubic centimeters, 25.4 cubic centimeters, then you know that is a burette. Gas syringe is used to collect gas, normally accurate to about 0.5 cubic centimeters. Volume of gas made in the reaction, hence gas syringe. Rule of thumb, the smaller the volume, the higher the accuracy required, the finer the apparatus. So you may have from cylinder, and then you've got the burette, and then finally the pipette. Now, we want to now look at the exam type questions before we wrap this one up. We need to look at the 5 steps most common lost marks are in the measuring questions or measurement questions. The scale division check is the single biggest one. Always ask yourself how many divisions are there between the units so that you're able to calculate. So it's very important. Now, reading skills. Work out one small division before reading. That's so true. So there could be something like between 0 and 1, there could be 5 lines. Therefore, it means that each division represents 0.2. Meniscus, read at the bottom of the meniscus. Reading at the top gives a value that is perhaps too high. Burette direction. Burette scales increase downwards. A reading of 7.5, then 32 means that 24.5 was delivered. So you also have to be careful there on the burette. The reading measures downwards from 0 to something units, or maybe from 4 cubic centimeters to 11 cubic centimeters downwards. All right. Choosing the apparatus. Underline the clue words exactly, accurately. Pipette or burette, approximately or about. That's going to be measuring cylinder. So if they say exactly or accurately, we are probably looking at pipette or burette. So if I could take you even back, I would love to do that. But eventually, you need to look at your notes and say which one is more accurate. Is it the volume? Is it the burette, which obviously measures a variable amount, and then volumetric pipette exactly. So we are looking at exactly, which would be pipettes, accurately perhaps a burette, but approximately and about should be a measuring cylinder. Units always include units, and they vary that. All right. Now let's have a look at the exam questions. Now let's see what we have here. Number 1, a student needs to add exactly 23.5 cubic centimeters of acid to a flask. Which apparatus should be used? So I would like you to pause and then you write your answer. You'd want to pause this video. Each question that pops up, I would encourage you to pause and write down the answer. We will then find out whether you were correct in the next slide that gives us the answers. So a student needs to add exactly 23.5 cubic centimeters of dilute acid to a flask. Which apparatus should be used? A, beaker, B, measuring cylinder, C, burette, D, gas syringe. Next question. And on this question, after reading, I would want you to pause and then write your answer before playing the video. Question 2. Which is the correct way to read the volume of water in a measuring cylinder? A, from above, top of meniscus. B, at eye level, top of meniscus. C, at eye level, bottom of meniscus. D, from below, bottom of meniscus. So you pause and you write your answer. Question number 3. Which apparatus is used to measure the mass of a sample of copper 2 sulfate crystals? Measuring cylinder, A, and then B, top pan balance, C, pipette, D, thermometer. So you can pause and then you write your answer. We want to see how many you would have scored in this question or in this section of exam practice. Question 4. A reading of a thermometer scale appears different when viewed from above. This error is avoided by A, using a wider thermometer, B, reading with eye level with the liquid, C, stirring the liquid faster, D, using a longer thermometer. Now let's go to the next question. I would also want you to pause after reading this question and answer the question. Number 5. Which apparatus delivers exactly 25 cubic centimeters of sodium hydroxide solution time after time? A, 100 cubic centimeter beaker. B, volumetric pipette. C, measuring cylinder. D, conical flask. You can pause and write your answer. So now we want to look at our answers before we go to the structured questions. Number 1, C. Burette. It delivers variable amounts accurately to the nearest 0.05. C. Number 2. Question. The answer for number 2 is C. At eye level, the bottom of the meniscus. This avoids parallax error. Top pan balance. 3. The answer is B. Number 4. Reading with the level with the liquid removes parallax error. Volumetric pipette designed to deliver one fixed volume very accurately. I hope you've taken note of those questions. Now let's have a go at the structured questions. 2 structured questions attempt both fully before we look at the marks scheme. Marks are shown per part as you can place yourself. Now, question 1. A student investigates how temperature changes when a salt dissolves in water. 1A. Name the suitable apparatus to measure 50 cubic centimeters of water for this experiment, worth 1 mark. B. State 2 things the student should do to obtain an accurate temperature reading. C. Explain why a digital stopwatch may not improve the accuracy of a hand-timed reading. Total of 5 marks. So you are to stop. In fact, you are to pause this video and you write the answers. At least you can have a glare at the questions and then you can write the answers down. We'll see whether you've scored everything or not. Number 2, a burette reads 6.5 cubic centimeters before a titration and 31 cubic centimeters after it. A. Calculate the volume of solution delivered. B. State why a burette is more suitable than a measuring cylinder here. C. Describe how to read the burette scale correctly, naming the error avoided. So you can pause these questions, and I believe that we get to look at the marking scheme. Now, when you pause this video, you are to write down the answers to those very questions, and you can only then resume if you want to learn to see how much you've mastered. You can only resume after you have read the questions. Now, for the marking scheme and structured questions, what I'm going to do now is notice the marking scheme is short and point-based. That is exactly how you should write, one clear scientific point per mark. Let's have a look at the answers. Question 1, A. Measuring cylinder. B. Bulb fully in the liquid, stir the liquid or stir the liquid. B. Read at eye level, waits for a steady reading. C. Human reaction time is 0.2 seconds or 1/20th of a second, which is much larger than the 0.01 second precision. And then also we have, it's supposed to say D and E, so the uncertainty comes from the person, not the watch. The uncertainty comes from the person, not from the watch. I believe that this is still for C anyway. Human reaction time is 0.2 seconds, which is much larger than the 0.01 precision. So uncertainty comes from the person and not the watch. The person's reaction time may limit accuracy. Let's go to the next question. The answer for the next question, of course, remember we see that the reading, the initial reading was minus 6.5. It was 6.5. So you're saying final reading minus 6.5 to get your volume to be 24.5 cubic centimeters. B. Burette measures correct to 0.05 cubic centimeters, far more accurate than variable volumes. Far more accurate for variable volumes. My bad there. And then C. Read at eye level with the bottom of the meniscus, and this still on C avoids the parallax error. So be sure to join me in the next session when we get to talk about chromatography and purity. And in this instance, I will be having more questions tailor-made for students who subscribe for my lessons. If you sign up for 9 classes or you come through to visit us for face-to-face classes, you can get my number below, +263 777 992 527 should you come in for more robust in-person face-to-face classes and with more revision material to prepare you for that final exam. Thank you for watching from wherever you are. Like, subscribe, and share to those who may be interested in signing up for online classes.